Alright, let's go in and practice again finding zero force members in a truss. This is called a K-Truss. Notice that we have this big capital K that is formed by these web members, and this one is symmetric on the other side, and so you get the K being reflected in the other direction. Now we don't need to know what the actual values of P and Q are to go figure out whether there are zero force members. Remember, there are two rules of thumb. If we have three forces, two of them collinear, the third is not. That would be like a T-joint like we have right here, that the members form a capital T. The stem does not have to be perpendicular here. It can be skewed over. Then its perpendicular component will be 0, which makes the whole thing, if it were inclined, to be 0. That would be rule of thumb number 1, and then rule of thumb number 2 is two forces only at the joint both would have to be then 0. So we go along in this structure and we say, alright, well, do we have any of these? Do we have any T-joints? And I see immediately, bam, right here at K, we've got a T-joint. And then here at O, we also have a T-joint. So those two are 0. If I go in and look at joint J, I got 1, 2 members, and it's a pin support, so potentially 1, 2 reaction components, although globally looking at what happens, that would be 0. But 1, 2, 3 forces, they're not collinear, so nothing there, and I would hope not, because that reaction would be non-zero, and this diagonal is going to take up the vertical component of that, and that's going to create a horizontal component that JK ends up handling. The same kind of thing is going to happen over here at joint P. And then the same thing happens at A. All three of those will be non-zero. All three of these will be non-zero. And wow, we don't have any other T-joints in this entire truss. Now, if we were to come up and decide that one of these diagonals was somehow 0, then maybe we'd end up with something that would go along, you know, we'd follow the ripple effect. But the thing is whatever the X component of BF is, FL has to have an equal opposite. So that means one's in tension, one's in compression, in order for that to work out from an X direction. Hey, you know, let's just show that free body diagram real quick. At F, we already know that KF is 0, so hey, these have to have X components that are somehow the same, and so that means that one of them is going to be in tension, one would be in compression. And note what had happened here. If that's the case, the X's can balance out. Both of these have a vertical component going the same direction. That means that the vertical would have to pick up something here in order for that to possibly be in equilibrium. Right? So, okay, that's kind of interesting the way that began to work out. Right? So these little joints in the middle of that K are actually kind of difficult to filter through and understand, and it may turn out that there are some other zero force members in this truss. It's just that you can't really see it by observation right now. You'd have to do something a little bit more sophisticated. So right now we only have two. Those two T-joints are what's going to give it to us for sure. The rest of them, I don't know, and I kind of doubt it.